Good morning, students. See, today's topic is the workshop, Geometric Anatomy of Physics. Now, what is the objective of this workshop? That is, I want to tell you. The objective is only one objective. See, it's a translation of the problem of physics from English to mathematics. What is physics? See, if I want to say, if I try to say what is physics, you can take it like this. It is a natural philosophy written in the language of mathematics, which tries to explain how nature works, and definitely not why. See, I give you an example. Suppose this ball. So if I release this ball, it comes down, right? Why? Gravity. If you release it like this, if you leave it like this, it's not physics. You have to back it up with a mathematical law how this ball is being pulled by the earth. So it's proportional to the product of the masses, inversely proportional to the square of the distance between them. These are not my words, I'm quoting Feynman. So physics explains how nature works and not why. Right, you can have a different law, but if it meets the experiment, it's fine. So our problem is this translation from English to mathematics. So why we can't translate? The reason is we cannot see the mathematics. See, doing mathematics, it's fine. When you are in +2 level, you do a lot of differentiation, integration, that's fine. The thing is, at that point of time, you are given the problem. This problem is already given to you. But what is the problem with physics? Physics has a two-level problem. First, point number one, you have to frame the problem in mathematics from English or whatever language you are given to. Right, so this framing the problem of mathematics, this is the first objective which I am going to teach you. The second part is doing the maths, doing the mathematics. As far as doing the mathematics is concerned, there are certain rules. Suppose you come to a differential equation. Suppose d2y dt2 plus omega square y is equal to 0. For example, you come here. Now, you are given a system which oscillates with a simple harmonic motion, angular frequency omega. You reach this point. After this, you solve this differential equation. Solution of this differential equation is by rule, where mathematics holds her logic by herself, right? She holds her logic and you will never make a mistake if you follow the correct rules. But framing this differential equation is the most difficult task. It appears simple because this is a differential equation this is a problem which you already know. But for example, let me suppose this ball, right? So if you release a particle, from above, it comes down. Suppose you are given a problem, it comes down, right? Or suppose this ball is rotating, you are asked to find the moment of inertia of the ball. As far as class 11-12 is concerned, the moment of inertia of these balls are given. Suppose if this ball is solid and if this ball is hollow, having the same mass, the moment of inertia of this hollow ball is more. Why? Because the masses are concentrated outside and moment of inertia is a geometric property. Also, material property definitely depends upon the mass, but it also depends upon the geometry. My point in telling you these things is, if I learn spherical polar coordinates, it's very easy for you to calculate the moment of inertia. See, these spherical polar coordinates is not in your syllabus in +2 level, that I understand, but the thing is, calculus, right? Calculus is ingrained in your syllabus. There is no integration in class 11. That's a big problem. And many people start calculus with ddx of sin x is equal to cos x. They don't see the problem. They don't see how function works. They don't see how function works, uh, whether that function is continuous, whether that function is differentiable. I shall be doing real life problems where you will be able to translate this English language, this where the problem of physics is written, to the language of mathematics. And in this course I shall be teaching three things. Number one, calculus. Number two, vectors. And number three is coordinate systems. I give you these three things. Number one is calculus. I shall not be teaching differentiation a lot or integration a lot, but the geometry of the calculus. Okay, what is the underlying geometry? How can I write a differential equation, or how can I write an equation where this varies as this varies as this, where I can integrate and or differentiate, or I can find different quantities, right? So geometric property of this, then vectors. This is another most important thing. I have already 9 lectures on vectors, but I shall do it fresh over here. Unit vectors I shall be stressing on, and electrostatic problems and problems on mechanics can be easily dealt with if you know vectors. But the thing is, you must understand the underlying geometry. And the third is the coordinate system. But I tell you, coordinate systems. But many people may say that I should have taken the course of coordinate system first. That's true. So I shall be doing this coordinate system, this Cartesian coordinate system first. Then I shall be doing calculus in 1D. Then I shall be doing vectors. Then we shall come to the coordinate system again to teach you few more coordinate system. For example, polar, spherical polar coordinates, cylindrical polar coordinates. Of course, Cartesian coordinates we have already done. So these things I shall be teaching. And most importantly, I shall be teaching this in a geometric format. I tell you one thing, for example, in calculus, right, you have seen this thing many times in your home. Suppose this thing, what is this? But in Bengali we say it mora, right? See, these sticks are straight. If you make a section, these two surfaces are hyperbolas, and this stick, if you rotate this stick about this axis, the surface of this mora is generated. And definitely if you look like this, if you look straight, only one point you will be able to see from this point to this point, where the maximum minimum matches. These are saddle surfaces. Those students are very much interested. I shall tell these type of surfaces, how these geometries look like. If I release a thing, how does the ball come through this surface? What's the trajectory? So people may, I give you another thing. I'll tell you another thing. For example, well, suppose this book, okay, you don't need to read the title. It's not for +2 level. Now this, if I keep it like this, and if I release a ball, thermocol, If I release a ball, it comes down like this. Okay, it comes down like this. I'll show you immediately. I'll show you immediately. Suppose if I release this ball, it comes down like this. It comes down like this, right? It doesn't go like this, it doesn't go like this. This line is called the line of greatest slope. Because if you take the angle, if you just draw a plane perpendicular to this, which cuts the horizontal, you get an angle. And that angle is more, that's the angle the highest. If you release the ball, it doesn't go like this, it doesn't go like this. It takes this trajectory only along the line of greatest slope. So I shall teach you few geometries. You will develop a sense of geometry to handle problems. There are certain things, there are certain words which are used in the problem, so you must be able to understand what exactly they mean. Okay, so I hope you will enjoy this course. I shall be taking a 3-day course, not a 2-day course, in this March. Please, people, those who are interested, please call me on this number. I give you my number, or you can ping me in the Facebook comment box. Phone number is 833580879, and Facebook page is Nilabjo Physics Toppers. This is a Facebook page, you can ping me there. I shall be posting this video in the Facebook. Okay, so ping me there. I hope you will be enjoying this course. Anyone can join, teachers, students, anyone can join. I think this is very suitable for students who are going for the JEE and they must understand the geometry of a problem to handle physics problems. Thank you very much.